In this video, we want to see how to set up a GRE over IPsec tunnel for the reasons we talked about in the prior video. To begin with, I'm going to set up just a basic GRE tunnel. No encryption or any security things going on here, just a GRE tunnel. Here's how we do that. I'm going to go into router R1 and I'll create a virtual tunnel interface by saying interface tunnel, and I'll just give it a number of 1. I'll assign an IP address that I'm going to be using for this tunnel, and I'll use a private IP address of 192.168.0.1, and I'm going to give a 30-bit subnet mask, 255.255.255.252, because I only need 2 IP addresses in the subnet, 1 on each end of the tunnel, and the tunnel interface is up by default, so I don't need to do a no shutdown. And now I just need to say who's the source of the tunnel and who's the destination of the tunnel. Well, this is going to be coming out of the bottom of R1 and going into the top of R4. So my tunnel source from the perspective of R1 is that interface of gigabit 0/1. And I'm going to that interface on the top of R4, gigabit 0/1, and it has an IP address of 198.51.100.2. So I'll say my tunnel destination is 198.51.100.2, and I'm done with the configuration on R1 for my GRE tunnel. Let's move over to router R4, and I'll give a mirror configuration. I'll say that I want to create a tunnel interface, and I'll give it a locally significant number of 1. I'll assign it an IP address of 192.168.0.2, again with a 30-bit subnet mask. From the perspective of R4, my source is going to be gigabit 0/1. I'll say tunnel source gigabit 0/1. And the tunnel destination is going to be gigabit 0/1 on R1. That has an IP address of 192.0.2.1. And we're done with our GRE tunnel configuration. In fact, we just saw an OSPF adjacency come up between R1 and R4 over that tunnel connection because it looks like they're adjacent to one another. It looks like they're tied together using that tunnel. Let's take a look at our GRE tunnel before we move on to IPsec. If I do a show IP interface brief command, we can see that we do have a logical tunnel 1 interface, and it is administratively up. Excellent. I can do a show IP OSPF neighbor command, and I'm on R4, and I'm a neighbor with R1 over that tunnel 1 interface. Again, it looks like I'm physically adjacent to R1. And now that we've configured and verified our GRE tunnel, let's move on to IPsec. Remember, there are 2 phases. There's IC Phase 1, also known as ISAKMP, and IC Phase 2, also known as IPsec. First, let's configure the IC Phase 1 policy that we're going to be using. Let's go back over to router R1 and go into global configuration mode, and I'll say crypto, and let's give some context-sensitive help. And right now I'm wanting to set up the IC Phase 1 or the ISAKMP policy. So notice there's an option for ISAKMP. I'll say crypto ISAKMP policy, and I'll give a priority number. I've only got 1 policy, so it doesn't really matter what number I give. I'll just say 10. And now I'm in ISAKMP policy configuration mode. From here, I can set up my encryption. Encryption options include triple DES, DES, and AES. That's the one we want. Advanced Encryption Standard. That's the strongest of all 3 of these. So I'll say AES. For authentication, we want to use a pre-shared key, and that pre-shared key can be generated using Diffie-Hellman. Diffie-Hellman is going to use asymmetric encryption to create a symmetric key to allow us to do symmetric encryption. So I'll say authentication pre-share, and the Diffie-Hellman group determines how secure it is. I'll just use group 2 for this demo, and I'll say exit. And since we're going to be using a pre-shared key, we need to specify what is that key and who can it be used with. Now in our example, in this lab example, I'm going to make the key easy to remember. I'll call it Kevin's key. And since we're in a lab environment, I'm going to make this key valid with any peer that wants to talk with us. To do that, I'll say crypto ISAKMP, and the key is going to be Kevin's key, and the address of any valid peer, I'm going to say anybody. To do that, I'll say 0.0. And the address of any valid peer, I'm going to say anybody. To do that, I'll say 0.0.0.0 space 0.0.0.0. That'll match anybody. And now that we've specified our parameters for Ike Phase 1, it's time to create a transform set for Ike Phase 2. And the elements of this transform set, that's what's going to be negotiated between our two routers when they're setting up this Ike Phase 2 or this IPsec tunnel. And a transform set, it's a collection of encryption and hashing algorithms, and we have to find a matching algorithm on our peer. So we don't have to specify just a single encryption algorithm. We could say we'll support any of these. And during that negotiation that happens again during Ike Phase 1, we can agree on, hopefully, a transform set. And we can also say that we're using a transport mode or tunnel mode that we talked about in the previous video. In this example, let's say we're going to use transport mode, which is going to encapsulate the payload rather than the entire packet. We're going to keep our packet size a little bit smaller by not encrypting the original header. To do that, I'll say crypto IPsec transform set, and let's give it a name. I'll call it KW train, and we'll use some context sensitive help. Here we're looking at our security algorithms, and I'm going to choose encapsulating security payload, which is more secure than authentication header, -AES. Let's use some more context sensitive help. And it says, okay, I know how you want to do encryption now. You're going to use AES. What about for integrity? How are you going to do hashing? So from this list, I'll say encapsulating security payload, -SHA secure hash algorithm, HMAC, which is going to do more than just hash a string. It's going to add a secret key to that hash. So if somebody intercepts it, they're not going to be able to generate a valid key. Let's enter that. And we can specify our mode as either transport or tunnel. Here I'm going to say transport. And the next thing we need to do is define interesting traffic. When we're setting up an IPsec tunnel, interesting traffic is traffic that is going to be sent through the tunnel. We can send traffic that's not interesting just fine. It's not going to be encrypted though. And we want to encrypt our GRE traffic. So we want to make GRE traffic interesting. To do that, I'm going to use an access control list. I'll say IP access-list, and it's going to be an extended access list, and I'm going to call it GRE-N-IPsec. And I'm going to permit GRE traffic from anywhere to anywhere. Again, because I'm in a lab environment, I'm not concerned about specifying source and destination IP addresses. And now we need to create a crypto map. That's going to be the connective tissue that ties everything together. The interesting traffic, the transform set, and we're going to point to our peer. To do that, I'll say crypto map, and let's name this VPN. We'll give it a sequence number of 10, and this is going to be for an IPsec tunnel that uses ISACEMP, which is what we typically use. So I'll say IPsec-ISACEMP. And it says this is going to be disabled until we specify a peer and a valid access list. Okay, let's do that. Let's also specify our transform set that we want to use to protect the traffic. I'll say match address GRE-N IPsec. What this is saying is any traffic that's matching that extended access control list, we're going to put that inside the IPsec tunnel. We're going to protect it. And what is matching that access control list? All of our GRE traffic. So let's enter that. Let's say how we're going to protect that traffic. We'll say set transform, and we'll give our transform set name of KW train. And who's my peer? Well, my peer is that incoming interface on R4, 198.51.100.2. I'll say set peer 198.51.100.2. We'll exit that. And now we need to apply this crypto map to the gig 0/1 interface, which is the interface we're using to send those GRE packets. Let's go into interface configuration mode for gigabit 0/1. And I'll say crypto map VPN. We've now configured GRE and IPsec on R1. Let's now go over to R4 and give a mirrored configuration. Oh, and notice that our OSPF adjacency went down because I'm encrypting traffic on R1, but I'm not encrypting it on R4, so that's caused an issue. Well, we're going to fix that, so no worries. Let's go into global configuration mode, and let's do this. Instead of making you watch me type in the exact same commands with a couple of IP addresses may be different, what I've done is created this in a text file where I can just paste it in. Again, this is simply a mirrored configuration on R4. Just for time's sake, I don't want you to have to watch me do it again. If you want to watch me do it again, you can just rewind and see me do it on R1, but I'm just going to paste in the configuration for R4. And it should be working now. Hopefully our OSPF adjacency will come back up, and there it is, so that's a good sign. Let's do some configuration verification on R4. First, I'll create some traffic. Let's see if I can ping the loopback interface on R1. Can I ping 1.1.1.1? Yes, I can. Let's now do a show crypto ISAKMP SA, and that stands for Security Association. And we see that we've got R1 and R4 acting as both source and destination. Our status is active for these security associations. That's all good news. But that was for IKE Phase 1. That was for ISAKMP. What about IPsec? Let's do a show crypto IPsec Security Association. Things look good here as well. In fact, we actually see evidence that we have encapsulated packets. Some of those were our ping packets, some of those might have been some OSPF packets, but we are getting confirmation now that we are successfully sending GRE traffic inside of our IPsec tunnel. And again, the big advantage of doing that is that GRE can encapsulate just about anything. IP, unicast, broadcast, multicast. It encapsulates those traffic types inside of GRE packets, which are unicast IP packets. We then take those unicast IP packets, put those inside of our IPsec tunnel, which can only protect IP unicast packets, and then we allow IPsec to do its security work of encryption and hashing. And that's a basic look at a GRE in IPsec tunnel configuration.